Good day, everyone. I'm Harold Omanga, and together with me is my thesis partner, Ms. Aprilyn J. Balmes. Our thesis, the development of a 3D printed spongy electrode design for microbial fuel cell using gyroid lattice structure. Our thesis advisor, Professor Christopher Ray S. Pamintuan.
The microbial fuel cell technology have increasingly become a topic of prospect because of its application in wastewater treatment and bioelectricity generation. Our study centers in the application of 3D printing in the design and the assembly of the microbial fuel cell system. And here we had created a 32 solid MFC system, which is quite a leap in the usual number of existing assemblies of 7 to 15 cells. We used a design of gyroid lattice structure to make room for properties such as bacterial adhesion, electron transfer, and electrochemical efficiency, and thus the term spongy was coined for the context of our study. So in our study, we aim to design a single-print microbial fuel cell assembly that is dedicated to submerging in wastewater system. We aimed to perform studies such as stacking studies, polarization study, and to measure the wastewater treatment efficiency of the system by measuring the pH, TDS, ORP, and the percent COD reduction of the system.
Now, here is our proposed experimental setup or the experimental design for the treatment of wastewater using 32 MFCs. And here is the actual produced setup for the experiment where the data are collected that is constructed after the sample of wastewater was collected, where it is treated right away for 3 weeks. During this initial period, the COD parameter for wastewater is examined by the laboratory simultaneously. For the technical part of the design of electrode, it is composed of three components. First is the anode, second was the cathode, and lastly the separator. The gaps from each component have a different function for the MFCs. The gap between the cathode and separator is 3 mm wide. This is to provide more oxygen for the cathode side of the electrode to capture more oxygen during operation. Furthermore, for the anode and separator, the gaps are dedicated on inhibiting oxygen to occur in the MFC chamber to provide an anaerobic setting during the MFC wastewater treatment. And here is one of the 32 MFCs fabricated. In this figure on the left, it shows that the gyroid lattice pattern was produced by 3D printing. The gyroid lattice in this setup, I believe, was 2 millimeters thick for the external anode part. Our study consists of 6 tests dedicated to the efficiency of the MFC's performance. Individual performance and resistances of the MFCs in terms of voltage and current generation are gathered every 3 days. This is to determine the wastewater system adaptation during the exposure to the anode material. For the hybrid connection of the MFC's configuration, there are a total of 16 connections produced by the setup of MFCs. This includes pure connections such as the series and parallel connection. Furthermore, the series hybrid connections or the series parallel connections are 4S to 8P to 28S to 2P. Additionally, for the parallel hybrid connection, it consists of 4P-8S and 28P-2S. It was observed that the voltage readings are somewhat different from the initial voltage from the first 3 days of the treatment, which is the pre-colonization stage of biological content in the wastewater chamber, and the final voltage reading from the 23-day treatment or the post-treatment. The inconsistent reading of voltage generation for the individual cell is observed due to the different overall resistance values measured in individual cells that are caused by which in my perspective due to the 3D print quality. The majority of cells in the post-treatment of wastewater produce voltage within the range of 200 to 500 millivolts, which is not that far from the regular MFCs. Furthermore, the calculated external surface area of the anode was about 0.012252 square meter, used to determine the power density of the MFC system for the pure and hybrid connections. For the example of the connection here is the 28S-2P, which gives us a 22 MFCs connected in series, leaving us with 4 MFCs connected in series also. This produces two groups of MFCs which then connected in parallel configuration, thus 28S-2P. Here is the cumulative pure series connection. The larger gap between the theoretical and actual voltage reading. From the theoretical perspective, a series connection will generate proportional growth in voltage generation, which dictate that in increasing the stack of individual MFCs, theoretically, it should increase its voltage generation. However, in the real-life application of a pure series connection of an MFC system, there is a significant voltage loss during the treatment and observed in different literature investigating MFCs in other configuration connections. This is due to the voltage reversal caused by difference of voltage generation of individual MFCs when they undergo large quantities of connected cells. For the pure parallel cumulative circuit connection, it produces better voltage generation than a series circuit connection. The theoretical voltage reading and the actual voltage reading are different in the initial stage of the MFC treatment. However, the theoretical and actual reading begins to produce the same values in stacked 32 cells. These results prove that the conceptual effect of stacking multiple MFCs in parallel configuration that voltage stabilizes in an average amount as the number of cells increases. And now for the discussion of hybrid connection, we start with the series and parallel hybrid connection. It is observed that the voltage generated by the hybrid connection possesses a unique output. However, the trend produced by the series parallel circuit allows the system to generate significant voltage and observe the actual current generation. The data shows that the current generation decreases for the 7-day trial period as the series connection increases. Incorporating a cumulative combination of stacked series parallel MFCs offered enhanced performance of the whole wastewater treatment. Now for the power and power density of series parallel hybrid connection, it shows that the cumulative series parallel hybrid connection resulting in a decreasing value trend. This indicates that as the series connection increases and the connected group in parallel decreases, it produces a lower power generation and power density of hybrid connection. These results indicate that the most efficient connection has a fewer MFCs connected in series, producing a more significant number of cells group to be connected in parallel. On the other hand, we have the parallel series hybrid connection. Um, in this connection, it is significantly observed that the voltage increases and the current generation increases as well. The result shows that even if the number of connected parallel MFCs increases, the voltage still produces an average value of 288.77 millivolts. Significantly, the hybrid connection 12P-3S has the highest value of voltage, such as 320 millivolts. Moreover, the hybrid connection reveals that a different view of how stacked MFCs generate current in this configuration. This also shows that the MFCs in parallel increases, the current generation also increases. The pure parallel connection found that it has the highest current generation of 115 microampere, and having 4P-8S with a less efficient hybrid parallel connection that only produces 19 microampere. Now for the power and power density of the parallel and series hybrid connection, it is significantly different from the series parallel hybrid connection. The same trend was revealed, such as the voltage current generation. The power and power density also increases as the parallel connection increases in hybrid systems. This is reflected that as the current generation increase the connection of MFCs form a pure parallel connection. The whole trial period suggests that both series parallel and parallel series hybrid connections have their own limitations, their strengths and weaknesses regarding the parameters of voltage, current, and power density generation.
The efficiency of an MFC system can be characterized by the whole cell polarization measurements, where the cell voltage is plotted against the generated current density at a given external resistance in order to obtain the maximum power density. We had compared the generated measurements from the data, and we graphed the polarization and power density curve of the pure parallel connection, by which it had obtained the maximum power density among all the connections, with the power density of 29.30 microwatts per cubic meter and the current density of 233.63 microamperes per cubic meter against an external resistance of 1.37 kiloohms. So here you can see the maximum power densities generated per electrical configuration against their external resistances. So here are the comparison of the maximum external resistances of each electrical configuration from 4P to 8S hybrid connection to pure series connection. The wastewater was tested for its ORP, its pH, and the TDS daily for a 2-week duration using a multi-parameter water quality monitor. In this slide, you can see the summative results of the 15-day water quality readings, wherein the ORP decreased from 48 to negative 7 millivolts. The pH ranged from 8.0 and 8.01, and the TDS decreased from 270 ppm to 239 ppm. So you can see from this slide the graph of the daily readings of the ORP and the pH. The ORP has linearly decreased from plus 48 millivolts to negative 7 millivolts. This decrease in ORP may be attributed to the biochemical reactions happening in the substrate, such as denitrification. On the other hand, we have the pH, wherein you can see a minimal change in the range of 7.72 to 8.28. The concentration of the total dissolved solids on the first day of the measurement was at 270 ppm and decreased to the lowest concentration of 225 ppm. While for the COD, the wastewater sample was sent to a laboratory, and the results of the COD on the initial was a 987 milligrams per liter, and after the treatment, it was reduced to 47 milligram per liter. Calculating our COD removal percentage, we obtained a 95.24% of COD reduction. So in conclusion, we have successfully utilized 3D printing technology to design an MFC assembly with a gyroid lattice pattern, which was chosen to increase the surface area of each cell, and we made a 32 cell system for the same objective. Moreover, our hybrid parallel connection showed significantly higher voltage and current generation than the pure series and its hybrid connections. Also, the maximum attainable power of our system is at 11.49 microwatts, and the power density of 29.30 microwatts per square meter was generated by pure parallel connection. And for the water parameters, the lowest TDS concentration was at 225 ppm, and the range of pH was 7.72 to 8.28, and the ORP decreased from plus 48 millivolts to negative 7 millivolts, which was attributed to the nitrification happening in the substrate. And finally, It can be concluded from the results that the 95.24% COD removal is considered efficient enough to keep up and even exceed the performance of existing MFC designs.